Hello, welcome back for another video for the final exam for Math 201 Statistics. This video is going to start with question 13. And it says, assume that the populations are normally distributed and that independent sampling occurred. We have population 1 that has a sample size of 13, the mean and standard deviation, and then population 2. And they want us to test that mean 1 does not equal mean 2 at the alpha point of 0.1 level of significance. So that's our hypothesis, and that's our step 1, basically, right? And our step 2, and our step 3, because it means it is going to be a T0 that we're going to get from the program because it's 2 independent samples. And because it is a not equal to, it's going to be shading on both sides. And we are just going to look at the p-value and compare it to alpha. So let's just go to Desmos to do that. And our Desmos program is the one for 2 means, which is less than 9.3. So I entered our sample size, the mean, and the standard deviation for population 1. And then the sample size mean and the standard deviation for population 2. And we are looking at a test of not equal to, so I'm clicking on that. And there is our p-value, 0.05. Oh, no. Yes, we are looking at in our here is our test statistic is 2.36, and there's our p-value. And there was something weird. My sample size is only 13. That's what I get for my glasses. So sorry about that. My test statistic is 2.29. P-value is about the same, 0.0558. When we go back to our paper, we can see that either way, we're still going to reject H0 because alpha is less than, p-value is less than alpha. So we do reject H0. So there is sufficient evidence to support the claim. And then part B says, find the confidence interval, which you can just use the program here. Make sure your confidence is just your alpha, not alpha divided by 2. Alpha, and it will take care of it for you. So if you click on the confidence interval, it's going to give you the lower at 2.25 up to 6.15. And this one again matches our hypothesis test because 0 is not in the interval. And if there were no differences, then 0 would be in the interval. 0 is not in the interval, so that tells us that there is a difference. And that's exactly what we concluded with the hypothesis test up above. There is sufficient evidence to support the claim that there is a difference between the two populations. Okay, the last question is question number 15. It says a statistics student heard that an individual's arm span is equal to the individual's height, but he believes that they are different. To test his hypothesis, the student collected a sample of students and measured their height and arm span. So here's a printout here. They think that they're different. So I've heard that too, that they're supposed to be the same, your height and your arm span. Okay, so let's look what the printout tells us. They're testing just to see if it's not equal to, and is it sampling dependent or independent? So this is so it looks like you would think it would be a paired setup, but it's not. So they just sampled people and got their heights, and then sampled people and got their arm span. But you would think it would be a an individual's arm span compared to their own height, but that's not how the data is taken in here. So this is an interesting question because you would think it would be paired differences, but it's not. So in this case, they're independent. It must be independent. Okay, how many people were sampled? It looks like they sampled 10 people because our degrees of freedom is 9. There must be 10. And degrees of freedom is 9. And the average difference is a negative 0.4. And the standard deviation is 0.781. And it looks like we're doing yeah, this was written wrong. This is paired. That crunch is incorrect because they gave us a T statistic. So that does tell us that we're definitely doing paired differences. They're dependent, and this is what it should have written down below here on letter F. I need to correct that. So this is the correct setup. The test statistic is a negative 0.512, and then this p-value is 0.6209. And the let's see here. So this shows that they are not it's a two-tailed, and at 0.05 would we say it's statistically significant? So that's looking at the p-value compared to the alpha, and the p-value is 0.6209, which is greater than, so we do not reject H0. And so Kay says, what is our conclusion? So we do not reject Yashiro, so there is not sufficient evidence to support the claim. And that is the end of the video. Catch me back for more.